All right, so we need to finish up our river lab. We need to see what this year's current data shows in order to understand where the river's health is at right now. So we have a couple things to grab to get set. First thing is we want to put this health overview into our notability. That's where we're going to be compiling all the data and deciding healthy or not. And then we're going to be looking at our data and the graphs showing this year at the river. So to complete this lab the best, we want to have two things on our screen. We want to be looking at this file in Notability along with our shared Google Slides that have all the data and the graphs. So you want to get that set up. In order to first figure out where the river's health is at, we want to know what are the current levels and the overall averages and compare those to the standard. Now, starting with stream flow, we don't have a standard. So we're going to work this first one together, and then you'll use the rest of the graphs and data to complete transparency, nitrates, and oxygen. The other thing you might want to reference as we're working is your water quality notes, right, where we have all of our details here. So this is a resource that you'll be able to use to complete your lab as well. So we're going to do stream flow together. Follow along with me, fill out your notability, and then you'll complete the rest on your own and submit. So looking at the Google Slides, the slides are separated out into 4 parts. We got the pink section here is stream flow, yellow, transparency, purple, oxygen, and green, nitrates. So we're going to do the stream flow section together, going back and forth between the data and the graph. So we're looking at current level. Current level is what we got for this year. All the classes compiled together. Rosemount collected stream flow for this year is 58.5. And we want to make sure we know the unit for all of these is cubic feet per second. We can either write it out like this or record it cubic feet per second, either way. So current level, that's for now, 2022. Our overall average, the one we calculated from last week, is 30.11. And again, we want cubic feet per second, either written out or shortcut like that. And again, stream flow is tricky because there's not a standard. There's not a number that says, okay, the river is healthiest at this stream flow. We just have to kind of compare it to each other. So that's what we have going on here. We want to compare, is the current level of stream flow higher or lower than our overall average? So looking at these two numbers, we should be able to make that quick comparison. The current level of stream flow, 58.5, is higher than the overall average that we typically see at the river. We now want to use this information to help assess what is the health of the river now and what maybe made stream flow higher than normal this year. So this is where we then go to our water quality notes. So I'm going to close up my data and I'm going to open up my water quality notes. And because my focus here is stream flow, that's where I want to focus my information on. Remember, our notes have definition, what makes it go up or down, what happens to the health if stream flow is higher or lower, and if those things are positive or negative. And that's what we want to be thinking about here. This current level can cause, we want to know what changes can be made because stream flow is higher than normal. What's changing? Is that good or bad? And then because, how do we know? So looking at our notes over here, we're focused on stream flow being higher than average. So that means stream flow is increasing this year. So looking at my notes, impact on river's health because of an increase in stream flow can cause, we've got first off here, more dissolved oxygen. So thinking about my current level, higher stream flow can cause more dissolved oxygen, and then we have to decide, is this a positive or a negative factor? So the fact that there's more oxygen in the river, well, that should be a no-brainer. That's a positive. And then we want to give our because. Positive because fish need oxygen, right? Fish have to breathe oxygen in the water. So higher levels means that the fish have more health, they're not stressed, they can continue to reproduce, right? They can thrive when there's more oxygen. But looking at our notes, increase in stream flow also means more erosion. So we have another change that we want to make sure we record. More erosion, which means more sediment in the water. So then again, we have to think about, is that positive or negative? So again, looking back at my notes, we have that labeled as a negative. We don't want more sediment in the water because of how, again, that can impact fish. It can clog their gills. It can mean less sunlight into the water, which means less photosynthesis. Essentially, lower transparency. So if I need a reminder on all those things, I can always pop back up here. Less transparency, but I got a good amount of information. So I first compared my numbers that I got from the Google Slides. I decided where that number was at. We noticed stream flow is higher than normal right now. If it's higher than normal, we looked at our notes to see increase in stream flow can cause what? What changed? Is that good or bad? And how do I know? And then the last question is, what can cause stream flow to go up in the first place? So that's where you're going to look at your notes right here, factors that influence stream flow, and you should have some notes about what makes stream flow levels increase. So finish this sentence. The current level could have been caused by what's happening to make stream flow go up. So you can pause and answer that right now. Okay, so there's our stream flow section. We're done with that. When we move on to transparency, nitrates, and dissolved oxygen, that's when you're looking back at the data. And for each of these factors, remember there is a standard. So when you're looking at transparency data here, you're first going to get the current level and the overall average, and then you're going to find what the standard is. And that's on the graphs as a red line. And you can use the key to see what that is. It also should be in your water quality notes. So you can look in 1 and 2 places for that. So comparing it to the standard, what we have for transparency, and then we're noticing how the current level matches to the standard and how the overall average matches to the standard. But every time when we think about health, we want to decide what is it right now in 2022. Whatever the standard is it higher or lower than the standard? That's what we're going to use for our health factors. And again, to do that, we just go back to our notes and say, okay, it's increasing, here's the impact. Is that good or bad? Or it's decreasing, here's the impact. Is that good or bad? So use the data, use your notes to complete this entire section, looking for details on these 3 remaining factors, and submit when you're done. As always, reach out with any questions that you have.